So we want to now consider what happens when we go from one fin to multiple fins. Here we have an array of n fins. Each fin has a heat current of Q sub F, and the base here has a total heat current of Q sub B. The total area for heat transfer is A sub T, and A sub T is the sum of the area of the base, that's the full base, A sub B, plus n times A sub F. A sub F is per fin, so we then multiply it times n, the total number of fins. The total heat current is Q sub T, and Q sub T is the sum of Q sub B, the heat current from the entire base, plus n times the heat current through each fin, Q sub F. We can plug in. We find then that Q sub T equals H times A sub B plus n times eta sub F times H times A sub F, and all of that times theta sub B. So we're able to pull out the excess temperature at the base. This is simply a heat transfer in parallel situation. And so we can sketch that out explicitly. We see that there is heat transfer through a resistor defining the base itself. That resistor has a resistance of 1 over H times A sub B. Heat can instead transfer through the fin, and that's given by the upper branch of this parallel heat transfer arrangement. In this upper branch, we have a resistance of 1 divided by n times eta sub F times H times A sub F. You'll see here that we have a factor of eta sub F since the entire fin is not at the temperature T sub B. So we need this correcting factor of eta sub F to make up for the fact that the fin has a different temperature along its entire length. We can also define an overall surface efficiency in the system. In this system, we have Q sub T over Q sub max, that ratio is the overall surface efficiency, eta sub naught. If we plug in for Q sub T, based on this expression down here on the left-hand side, and for Q sub max as H times A sub T times theta sub B, that is just the maximum amount of heat that can be dissipated if the entire fin is at theta sub B, we end up with this ratio shown here. If we do some math and simplify, we get to this expression, which then further simplifies to this final expression for the overall surface efficiency. You'll see that it depends on the number of fins as well as on the efficiency of each individual fin. So we now have a way of handling multiple fins that are dissipating heat together.